Hi Kipsters, Miss Erford here. Today is Wednesday, May 6th, and here are some more math problems for practice. Today's problems are all about equivalent fractions. Fractions are set up as the part over the whole. The top number in the fraction is the numerator, while the bottom number is called the denominator. Equivalent fractions can have different numerators and denominators so long as they represent the same part of a whole. For example, let's start with 1/2. If the whole is divided into more equal pieces, you can create fractions that are still a half of the whole, such as 2/4 or 3/6. To find equivalent fractions, you can multiply or divide the numerator and the denominator by the same number. In other words, you can multiply or divide by a fraction equal to 1 to create an equivalent fraction. In the examples, they're multiplying and dividing by 2/2, which is equal to 1. Question 1 has 3 parts. In each part, you're given a fraction. For part A, that fraction is 5/10. Your job is to find out which of the choices are equivalent to that given fraction. There may be more than one answer. Question 2. Is 2/14 equivalent to 3/7? Prove your response using a multiplication sentence. You may also find it helpful to draw fraction models for these questions, where you draw a rectangle and partition it to show the original fraction, and then either add more partitions or remove some to create the equivalent fraction. For question 1, I have written equations to try and create the equivalent fraction from 5/10 to the given options. The first one you can see with 5/10, I can divide 10 in the denominator by 2 to get 5 in 2/5. However, I can't divide the top or the numerator to get the 2 in 2/5, so that is not equivalent. For the second one, it has the opposite problem. I can multiply the numerator in 5/10, 5 times 2, to get the 10 in 10/15, but if I did the same on the bottom, I would not get 15 in the denominator. So 10/15 is not equivalent. Fortunately, the bottom two, 3 and 4, you can multiply the numerator and the denominator of 5/10 by the same number and get the equivalent fraction. 15/30 and 10/20 are equivalent. Here are fraction models to represent these equivalent fractions. They began as showing 5/10 and then were further partitioned by the dotted lines to create an equivalent fraction. The dotted lines show each tenth being multiplied by 2 or 3, which matches our equations from the previous slide. You may also notice that each of these fractions is equivalent to 1/2. For part B, you may have discovered that many of the choices are an equivalent fraction to 3/4. As you can see in the equations, 3/4 can be multiplied by 2/2, 3/3, and 4/4 to create 6/8, 9/12, and 12/16. The only fraction that is not equivalent to 3/4 is 5/6. Again, here are fraction models to help you further understand these equivalent fractions. The original fraction of 3/4 is multiplied into more equal pieces by those dotted lines, either by 2, by 3, or by 4 to create the equivalent fractions. For part C, there are two options that are equivalent to 1/8. The first option of 6/14 did not work. I can multiply the numerator times 6 to get the 6 and 6/14, but I could not do the same on the bottom to get 14 in the denominator. 2/16 and 3/24 are equivalent because I could multiply 1/8 by 2/2 or 3/3. And the final choice, 2/4, did not work. For the same reason as the first, I can multiply the numerator by 2 to get the 2 and 2/4, but I could not do the same on the bottom or the denominator to get the fourths. Going from eighths to fourths would require division. Here are the fraction models to show that 1/8 is equivalent to 2/16, and 1/8 is also equivalent to 3/24. Lastly, let's review the answer to question 2. Is 2/14 equivalent to 3/7? Prove your response using a multiplication sentence. To determine whether or not 3/7 is equivalent to 2/14, I considered the comparison between the numerators and the denominators. I noticed that 7 times 2 could get me 14. So I chose to multiply 3/7 by the fraction 2/2. That fraction is equal to 1, so that's okay. I'm multiplying the numerator and the denominator by the same number. However, in the numerator, 3 times 2 would get me 6. Therefore, 3/7 is not equivalent to 2/14. Great job solving those problems, Kipsters. If you have any questions about this video, be sure to reach out to your teacher. Tune in tomorrow for another set of math problems.